the minimum value of 3x plus 5y such that 3x plus 5y lesser than equal to 15, 4x plus 9y lesser than equal to 8, 13x plus 2y lesser than equal to 2, and x greater than equal to 0, y greater than equal to 0. So we need to minimize this function. Let's say this function be z. So z will be equal to, let's say z is equal to 3x plus 5y. Let it be equation number 1, and we need to minimize z. Okay, so that means we need to find the minimum value of z. Now let's understand this problem in the graph sheet. Okay, so let's draw the graph and represent all these functions. Let's say the horizontal axis be x and the vertical axis be y. The first equation given to us, let's write number 1, 3x plus 5y is lesser than equal to 15. Now let's represent this function on xy plane. So this line represent 3x plus 5y is equal to 15. This is 0, 3, y-intercept is 3, and the x-intercept for this line is 5, 0. Okay, this point 5 is the x-intercept. The second line given to us is, or the second function we can say, 4x plus 9y is lesser than equal to 8. Now let's represent this function on this xy plane. So the green line represent 4x plus 9y is equal to 8. Y-intercept is 2 and x-intercept here is 8 by 9. The third function given here is 13x plus 2y lesser than equal to 2. 13x plus 2y is equal to 2 is represented by this red line. The y-intercept is 1 and x-intercept is 2 by 13. Now the fourth condition given in here is x should be greater than equal to 0 and y should be greater than equal to 0. That means it is whatever the value will be, it is only in first quadrant. And if we use all these four conditions, the only possible region that we can get is this hashed region, this hashed yellow region. Now the endpoint of this region is A, B and point C. So the coordinate of C is 2 by 13, 0, B is 0, 1 and A is the origin, so it's 0, 0. Now if we find the value of Z at these points A, B, C, we can find the minimum value of Z. So let's write Z at B. Let's find Z at B first. Now Z is given by 3x plus 5y. Okay, so let's write here Z is equal to 3x plus 5y, and we need to minimize this function. Okay, we need to minimize this. So Z at B will be, at B y is 1 and x is 0. So 3 into 0 plus 5 into 1, that is 5. Z at C is equal to 3 into 2 by 13 plus 0 into 5, that will be equal to 6 by 13. And Z at A is equal to 3 into 0 plus 5 into 0, and this is equal to 0. So we see here the minimum value of Z is 0 and that is at point A. And also here we can see that Z is maximum at point B, that is 5. Now let's go back to the problem. So we needed to minimize this 3x plus 5y and the value is 0. For reference, you can refer to the NPTEL course lecture number 1, Introduction to Optimization on Computer Aided Applied Single Objective Optimization by Professor Prakash Kotecha of the Department of Chemical Engineering at IIT Guwahati.